Hi students, now we are going to derive an expression for the work done by a variable force. Now, what is meant by a variable force? Suppose you are pushing or pulling an object with some force initially. The object is moving. Suddenly, if you pull harshly or very slowly, then the force applied on the object is going to vary. So such a force only is called as a variable force. Now look at this picture. We have considered an object, a wooden block which is kept on the horizontal surface, and it is tied to a string along which a force F is initially acting. So I am going to pull an object with a rope. So initial few steps I am slowly walking and gently pulling. Suddenly if I will run very fast dragging the object, then the force increases. Then again I stop for a while or I slow down once again so that the force acting on the object also will be reduced. So when the magnitude of the force acting on the object is continuously changing, either increasing or decreasing, then such a force only is called as a variable force. However, whether the force is variable or constant, work will be done. Okay. Now let us say that the object is moved from a point A to a point B with an initial displacement Ri to a final displacement F along a straight line. Let F be a variable force now. It is going to change in magnitude. Okay. Now, in this case, in between the 2 points A and B, let us choose a very small separation distance dr, that is called as infinitesimally small displacement. So as usual, that small work done is given as a dot product of force and displacement. So dw is the small work done for a small displacement dr. So this is equal to this F dot dr, and the dot product of these two vectors will be a scalar, that is equal to F into length dr into cos of the angle theta between the two vectors. So the total work done from A to B must be W equal to integral of dw. Here also it is integral of F dot dr, that is equal to F cos theta into dr. If the force is a constant force, then this F and theta can be taken out of the integral because the displacement only is a variable. But in this case, the force also is a variable along with the displacement. So we cannot take F cos theta out of the integral. Therefore, the total work done in this case is equal to integral of F cos theta into dr between the limits R initial to R final. So this is the expression we have to integrate. So look at the graphical representation of the work done by variable force. So initially when the displacement was R initial, F cos theta was equal to 0. Then as the displacement changes or increases, can you see that the force initially was increasing? Then here in this portion almost constant, then again it is increasing and it has reached the maximum, and then it is declining or decreasing like this, and finally it comes to 0. So such a force whose magnitude is changing always is called as a variable force. In such a case, you can join all the points and get a closed curve like this. So in the case of constant force, we got a graph like a regular geometric figure such as a square or rectangle. But in this case, you see the closed curve is not a regular figure. It is some irregular shape you are getting. How to find the area? So for that only the method of integration or area finding. Okay. So the entire area is split into several small strips, rectangular strips. Say for example, I will take this small strip, any one strip like this. Okay. So these 2 points are these 2 points I will take. So I will take 2 close points like this, so that the spacing between the 2 points is equal to the infinitesimal displacement dr. So between these 2 points, the height is almost the same, isn't it? If you take this point and this point, means their heights are too different. But if I will take two close points, almost the height is the same. So this height can be taken as what? F cos theta. So the height or the length of the strip is equal to F cos theta, and the width or the breadth of the strip is equal to dr. So that the area of one small strip is equal to F cos theta into dr. Like that, each strip will have some area, that is length into breadth. So if I add the area of all the strips, the total area of this closed curve we will get. So that is called as integration method. So you add the areas like this for all the rectangular strips like this, that will be equal to the total area that is given by this integral F cos theta dr between the limits r I to r final. So work done by a constant force as well as work done by a variable force, in both the cases, graphical method, the area under the closed portion gives you the work done from the initial to the final point. I hope you must have understood this well. Fine.